So guys, we are continuing with exercise 12C, question number 15. Okay. If I read the problem for you, it is given as an open box with a square base. So there is one box. The base is square. Okay, the base is square. So we are not very sure about the vertical walls, whether it is a square wall or not. This wall is a square wall or not, we are not very sure. But then the base is a square. This is for sure it is a square. So length and breadth is same, that is x, and the vertical height is y. Now, since this is a open box, when we consider the area of the entire box, we will not consider the area of the top. We'll only consider the area of the bottom. Okay. So area given, the total area given is area is equal to c square. So when they say area equal to c square in the problem, right? So that indicates it is area of the base plus 4 times area of the vertical slides. Okay, is equal to c square. So area of this base is a square, so it is x square plus 4 times area of the vertical sides. So this is a vertical side, it's a rectangular side, we are not very sure whether it's a square or not. So the area of this particular side is length into breadth, which is x into y, and there are 4 such sides. So x square plus 4x square is equal to c square. So x square plus 4xy is equal to c square. Okay, we'll get the value of y over here. Y is equal to c square minus x square upon 4x. Okay, now we'll find out the objective of the problem. It will be either to maximize or minimize. So objective, to maximize volume, it's given in the problem. So volume is equal to length into breadth into height. So volume is equal to length x, breadth x, height is y. So I'll take you to the slide where I have drawn the diagram. This is the length, this is the breadth, and this is the vertical height. Okay, so that's how we calculate the volume of the box. Right, x into y, which is x square y. So v is equal to x square into y. Now what is y? Y is c square minus x square upon 4x. C square minus x square upon 4x. Now since 4 is a constant, we can shift it over here. So 4 times volume is equal to this x square, and this x will get cancelled. So we are left with x into c square minus x square. So 4 times volume is equal to c square x minus x cube. So this becomes your f of x. Okay, function of x. We can only move the constants on the other side. We cannot take the variable on the other side. 4 is a constant, so I took it on the other side. Okay, now f of x is equal to, what is f of x? Just let me go back. C square x minus x cube. C square x minus x cube. F dash x is equal to c square minus 3x square. F double dash x will be minus 6x. This is our standard procedure. Now what maxima minima says? Step 1, equate f dash x to 0. Equate this to 0. So c square minus 3x square is equal to 0. C square is equal to 3x square. So c square by 3 is equal to x square, right? X square is equal to c square by 3. Right, now this is also important because x square will be used somewhere, and x is equal to c by root 3, taking square root on both the sides. These two values are important. Now we got the value of x. You are going to put this value of x in f double dash h. Put x is equal to c by root 3 in f double dash h. f double dash x is minus 6x, which we have calculated previously, minus 6x, right? So minus 6 c by root 3. Now this turns out to be negative. We did not solve this, but then it is negative because of the minus sign. Therefore, f of x has maxima at x is equal to c by root 3. Okay, we got the maxima. Now we have to find out the maximum volume also. Okay, before that we'll try to find out the value of y. Now y we have written as, see, somewhere we have written y, c square minus x square by 4x. Okay, so y is equal to c square minus x square by 4x. So c square minus x square. What is x square? We have highlighted over here. C square by 3 divided by 4x. 4x, right? So what is x? C by root 3. You can speak. Are you able to understand this thing?
Yes, sir.
Root 3 by 4c. So 2c square by 3 root 3 by 4c. 2 ones are 2 twos are. So root 3 by 3 c. That is the value of y because c square upon c is c. This is the value of y. Okay. Now the last part, volume. Volume is equal to length into breadth into height. So x into y. Did you understand this?
Yeah, sir.
So sorry.
So, won't y be c? Sorry, won't y be 1 upon root 3 c?
Same thing. Same thing.
Okay.
So this is the x square y. Now what is the value of x square? The value of x square is c square by 3. Okay. And the value of y. The value of y we have just calculated. Root 3 by 3c. Okay. So now this one of the threes, I'll just write it as root 3 into root 3. Now this root 3 have written it as root 3 into root 3. And c square into c will be c cube. So one of the root 3 will get cancelled. Right?
Sir, it is
Yeah.
root 3 upon 6, not root 3
6,
upon
6, 6.
6.
Correct. Root 3 upon 6. Sorry. So this is root 3 by 6. The value of y. Okay. Now what I'll do is I'll change the 3 which is there in the denominator as root 3 into root 3. Now why we are doing this is because the problem is asking us to prove something. Okay? What is it asking us to prove? That the maximum volume is c cube by 6 root 3. So one of the root 3 will get cancelled. So this will be 6 cube by 6 root 3 cubic units. So that's the volume. Do you have any further doubt?
Sir.
We'll start with the next problem. Are you done copying this?
Yes, sir.
Let's go to question number 16. Okay, I'll erase this now. Yeah. So question number 16 from the same exercise. A cylinder is such that sum of its height and circumference of the base is 10 meters. So what is given? Sum of the height, the vertical height, plus the circumference of the base. Circumference of the base is 2 pi r is equal to 10. Do you have any doubt in this? Do you have any doubt in this?
No, sir.
Okay, so basically this is given. Now h in terms of r or r in terms of h, that decision we'll take later on. First, we'll find out what is the objective of the problem. The objective of the problem is to maximize the volume of the cylinder. So I'll write down the objective to maximize volume of the cylinder. So volume, what is the volume of a right circular cylinder? It's pi r square h. Okay. Now r square I'm not going to disturb. I'll just find out the value of h. So v by pi is a constant, r square into h. Now h value is equal to 10 minus 2 pi r. Did you understand?
Yes, sir.
So h value is 10 minus 2 pi r. So 10 minus 2 pi r I am writing in place of h. So v by pi is equal to 10 r square minus 2 pi r cube. So let this be f of r. V by pi, let it be f of r. Do you agree with me?
Yes, sir.
Yeah.
Yes, sir.
So we'll find out f dash r and f double dash r. F dash r equal to 20r minus 6 pi r square, and f double dash r equal to 20 minus 12 pi r. We have calculated both. You can copy, I'll wait for you.
Sir, done.
Okay, so step 1, f dash r is equal to 0, right? So you can equate this. 20r minus 6 pi r square is equal to 0. 20r minus 6 pi r square equal to 0. So 20r is equal to 6 pi r square. Okay, one r will get cancelled. So r will be 20 upon 6 pi 10 by 3 pi. This is the radius. Do you agree with me?
Yes, sir.
Okay, so we can put this r is equal to 10 upon 3 pi in step 2. That is f double dash h. Let me know once copied.
Yes, sir. It's done.
Yeah. Step 2, put r is equal to 10 by 3 pi in f double dash r. Now f double dash r, we have already calculated. The value of it is 20 minus 12 pi r. So 20 minus 12 pi r is 10 by 3 pi. So pi is getting cancelled. 3 ones are 3 fours are, and this is 40. This is minus 20. So this is negative less than 0. Therefore, f of r has maxima at r is equal to 10 by 3 pi. Okay. Now once we get the value of r, we'll find out the value of h. So you can calculate the value of h. Okay. Let me know once done. I'll go to the next step.
Yes, sir. Done.
Yeah. So h is equal to 10 minus 2 pi r. We have already calculated the value of h. over here right at the beginning, 10 minus 2 pi r. Okay, so that is the value of h. Now put the value of r over here as 10 by 3 pi. So pi is getting cancelled. So 10 minus 20 by 3, which is equal to 30 minus 20, 10 by 3. I got the value of h as 10 by 3. This is the vertical height of the cylinder. Units you can mention whatever the units are there in the problem. Now volume of the cylinder is pi r square h. So put the value of r and h. H is 10 by 3 and somewhere we might have calculated r square or r. So r is equal to 10 by 3 pi. So r square will be 100 by 9 pi square. So this will be 100 by 9 pi square. Okay, so this will be 1000 upon 27 pi. You can put the units, cubic units or cubic meters for this problem. Let me know if you have understood this problem.
Oh, I understood, but the thing is, Abhi, in the starting, you had taken volume upon pi is equal to f of r. So is it
Yeah,
okay to do that? Like, I don't know why you did that.
see pi is a constant. To make the calculation simple, I've done that.
Oh. And so if we directly substitute the value of r like in this equation, r and yeah, then also we'll get the same answer.
No, we won't get the same answer. We'll get the answer of v upon pi. We'll not get the answer of v. Hence, after
Oh,
calculating r, I am first calculating h. And then, as per the normal procedure, I am calculating pi r square h. Fine.
yes, sir.
Yeah. So I'll take you to the next problem. That is question number 18. Question number 18. Show that the height of an open cylinder of given surface and the greatest volume is equal to the radius of the base. So we have an open cylinder. See, there is very important word mentioned over here. Given surface. That means surface area of the meaning of given surface I am telling you. The meaning of given surface implies surface area of open cylinder is constant. So surface area is equal to K. Okay, now when we speak about the surface area, it will be curved surface area and the area of the base. It will be the curved surface area and area of the base. We will not consider the area of the top because it's an open cylinder. Chalo, is this discussion clear for you? Yes or no? Hello? Is
Yes,
this
sir.
clear for you? Yeah. So surface area is constant. Have you copied this?
Yeah, sir.
Yeah. So surface area is equal to K. That means area of the circular base plus area of the curved surface of the cylinder is equal to K. Area of the base is pi r square. Okay. And when we speak about the curved surface area, so do you know what is the curved surface area? Two pi r h. Okay. The curved surface area of the cylinder is 2 pi r h. And we are considering the area of the base as pi r square. It's the circle. This much is clear.
Hmm.
Okay, now R in terms of H or H in terms of R, that decision will take later on. Now the objective of the problem is to maximize the volume. Objective. So volume of a right circular cylinder. Right circular cylinder is nothing but pi r square h. Okay. Now we are not going to touch this r square. So r square remains r square. We'll just find out the value of h. And we have taken the constant pi on the other side to avoid, you know, lengthy calculations. Constants you can move. So 2 pi r h is equal to k minus pi r square. So h is equal to k minus pi r square upon 2 pi r, where k is a constant. Okay.
Yes, sir.
So put the value of h, k minus pi r square upon 2 pi r. Okay, now pi will get cancelled. You can send that 2 on the other side. R square r will also get cancelled. Fine. So we are left with r into k minus pi r square. So f of r is equal to kr minus pi r cube. Kr minus pi r cube. Did you understand? F dash r is equal to k minus 3 pi r square, and f double dash r is equal to minus 6 pi r. We got the value of f dash r and f double dash r. Chalo, tell me, clear this much, or you need some understanding? F of r is not volume, f of r is 2 times volume. Just remember that.
Yes, sir.
Copied?
Yeah.
Step 1, f dash r is equal to 0. So k minus 3 pi r square is equal to 0. So k is equal to 3 pi r square. R square is equal to k by 3 pi. This implies r is equal to root k by 3 pi. Okay.
Yes, sir.
Then what we will do after this?
We will substitute the value of r into, no, sorry. Yeah, we'll substitute the value of r and we put that in f double dash r.
Correct. So put the value of r in f double dash h, f double dash r. Now f double dash r equal to minus 6 pi r. No need to solve this. It's less than 0 because of the minus sign. You agree with me?
Yes, sir.
So f of r has maxima at r is equal to root of k by 3 pi. Now see, they are not asking to find out the maximum value, maximum volume. Okay, they are just asking us to maximize the volume. To find the maximum value is not required. They have given show that the height of the open cylinder of given surface. Given surface means surface area is constant of the open cylinder and greatest volume. That is nothing but the volume is maximum over there. They're not asking calculate the volume also, but then they're asking us to prove that height of the cylinder is equal to radius of the base. So we'll first calculate h now. Now h is equal to k minus pi r square upon 2 pi r. K minus pi r square upon 2 pi r. So we'll put the value of r square and r. R square is equal to, I've highlighted it, k upon 3 pi. So pi and pi got cancelled. Divided by 2 pi r. R is nothing but k upon 3 pi. Square root of k by 3 pi. So 3k minus k is 2k by 3 into, now see this 2 pi will go down, and along with that this k by 3 pi will also go down. So this 2 and this 2 is getting cancelled. So we are left with k by 3 pi. See, k by 3 pi. If you observe very clearly, k by 3 pi, the whole upon root k by 3 pi. This is your height. So what is x upon root x in mathematics? Can you tell me what is x upon root x?
Upon root x. Root x upon, yeah, root x.
X upon root x is root x. So h is equal to root of k by 3 pi. Did you understand?
Yes, sir.
H is equal to root of k by 3 pi. Therefore r equal to h. Hence proved. R is also root of k by 3 pi. H is also root of k by 3 pi. Correct? Do you have any queries in this problem?
No, sir.
We'll go to the next problem. I think I forgot question number 17. Right?
Okay, sir.
Okay. Should I erase this entire piece of information?
Yes, sir.
Okay. Now go to question number 17. Okay. Question number 17. A right circular cylinder is made so that sum of the radius and its height is 6 meters. So given sum of the radius of the base and the height is 6. Okay. Objective. Objective is to maximize volume and to find the maximum volume as well. So volume of a right circular cylinder is pi r square h. So V is equal to pi r square. H is equal to 6 minus r. So 6 minus r. So V upon pi is equal to 6 r square minus r cube. So this becomes f of r. 6 r square minus r cube. Tell me, have you understood this or it's unclear?
Yes, sir.
So f of r is equal to 6r square minus r cube, f dash r 12r minus 3r square, f double dash r 12 minus 6r. Step 1, f dash r is equal to 0, 12r minus 3r square is equal to 0, 12r is equal to 3r square, so r is equal to 4. Okay, r is equal to 4. Fine.
Yes, sir.
Now put r is equal to 4 in f double dash r. You can try that. I'll wait for you. So step 2, 12 minus 6r less than 0. Therefore, f of r has maxima at r equal to 4. Now h is equal to 6 minus r. So 6 minus 4, which is equal to 2. The value of h is 2. Right? Yes or no?
Yes, sir.
So how to solve further now? How to calculate the volume of the cylinder?
You substitute the values of H
Correct.
and R.
Correct. So volume is equal to pi r square h. So pi r, what is r? R is 4, h is 2. So 32 pi cubic units or cubic meters. You can put the units. Volume is equal to 32 pi cubic meters.
Done, sir.
We'll go to question number 23. Okay, just read the problem. See, let us understand the data given in the problem. 23. Right, circular cylinder has volume 2156. So this time volume is given 2156 cubic units. The volume is given to us, right? Okay, so what is the volume of the right circular cylinder? Pi r square h, that is 2156. 2156. Now this is given. Now h in terms of r or r in terms of h, that decision will take after a while, not now. Okay, that decision we are supposed to take after a while, not now. Now what we'll do is we'll try and understand what is supposed to be maximized or minimized. So if you read the problem, they have clearly mentioned in the objective to minimize the total surface area. Okay, so I'll just write down the objective on the next page. Objective to minimize total surface area. Now this time the cylinder is not open from the top. The cylinder is not open from the top.
Yeah.
Okay, so total surface area is equal to area of the bottom and base, and these both are squares, plus area of the curved surface. So area of the bottom and base is pi r square individually. So this will be pi r square plus pi r square. Do you agree with me? And area of the curved surface. Area of the curved surface is 2 pi r h. Okay, so the total surface area is 2 pi r square plus 2 pi r h. Okay, so we'll find out the value of h now. R square and r we are not going to disturb. Square terms you don't disturb it. Simple terms you take. So h is the simple term. Let's go back to the previous slide. So h is equal to 2156 upon pi r square. This is the value of h. This is the value of h. So this we are going to substitute where? Over here. Are you understanding?
Yes, sir.
So total surface area is equal to 2 pi r square plus 2 pi r h. H is equal to 2156 upon pi r square. Okay, so this time this pi and this pi is getting cancelled. One of the r will get cancelled. Okay, so total surface area is equal to 2 pi r square plus 2156 into 2. What is the multiplication of that? 2156 into 2.
4312.
Correct. 4312 upon r. So now nothing is common over here. Nothing is common. So we'll just keep it as it is. So this becomes f of r. We'll calculate f dash r. F dash r will be 4 pi r minus 4312 upon r square. The derivative of 1 upon r is minus 1 upon r square. Do you agree with me?
Mm.
Okay. Now f double dash r. That is also quite crucial. Have you copied this much?
Yes, sir.
So f double dash r equal to 4 pi r. Derivative of 4 pi r is 4 pi minus 4312 d by dr of r raised to minus 2. See, if we have to derivate r square, which is there in the denominator, first we have to take it up, right? As per the indices, and then derivative. Okay. So 4 pi minus 4312 minus 2 r raised to minus 2 minus 1, that is minus. What is 4312 into 2?
8624.
Upon r cube, right? This is f double dash r. Now what we will do after this? Someone tell me.
Step 1, f dash r is equal to 0.
F dash r is equal to 0, right? And see, they are asking us to minimize total surface area. No need to find out the total surface area, okay, at the end. And what should be the radius of the face? So r to mil jayega. So f dash r, what is f dash r? 4 pi r minus 4312 upon r square. So 4 pi r is equal to 4312 upon r square, right? So r cube is equal to 4 pi 4312 upon 4 pi, right? R cube 4312 upon 4 pi. Now put the value of pi as 22 by 7. They have asked us to do that. And then you can take the 7 up in the numerator. Chalo, calculate the value of r cube. You have a calculator, so you can calculate the value of r. Are you getting the value of r cube?
R cube is 343. So,
R is 7.
R is 7.
Now put step 2 now. R equal to 7 in f double dash r. Now what is f double dash r? 4 pi plus 8624 upon 7 cube. Now there is actually no need of solving this. Just by looking at this, can we tell it is greater than 0? By any chance this is
Yes.
going to be negative?
No.
So why to waste time in solving this? So this is greater than 0. Therefore, f of r has minima at r is equal to 7 centimeter or 7 units, whatever you can just mention it. That is the end of the problem.